Okay, so this is a little review unit on simplifying radicals that you should be familiar with from Algebra 1. And so a radical is another term for a square root. And a square root, if there's not a number here, we know that it's 2. Sometimes you're going to have cube roots. Sometimes you're going to have fourth roots. But we're going to focus on square roots. And again, if it doesn't have a 2 there, you know it has a square root. The difference between all these is what it takes to get something out of the root. When you have a square root, in order to take something out, you have to have groups of 2. And so I can take out one group of 2. For a third group, you have to have groups of 3. So I can take out one group of 3. And then a fourth root, you have to have groups of 4. And so I could take out one group of 4. All right, what we're going to do with our problems down below is we're going to look at prime numbers and prime factorizations and see how many pairs or partners do we have, because all of the ones we have are going to be square roots. So one thing that might be helpful if you don't know all your squares is just to have them written somewhere. But so 2 squared is 4, 3 squared is 9, and so forth. So you might want to get a table or write those down. If you're not good with your squares, that's okay. What we'll do is we'll do a factor tree. And when we do a factor tree, I just try and find my prime numbers. So these are the numbers that I want to break things down to. What's next? 11, 13, 17. Okay. Anything that's not those numbers, I need to break it down into some of those, into some of these. Okay. So 4 is the product of 2 and 2. I can break down 2 again, but I just get 2 and 1. So this is the what you get. And so in order to take it out of the square root, I have to have a pair, and I have 1 pairs of 2's. So my answer is just the square root of 2. All right, here, 25 is just 5 times 5. And again, I have to have a pair, and I have 1 pair. So my answer is just 5. So these were pretty easy to see because 2 squared is 4, so we take the square root, that's why it's 2. And sometimes we're going to have numbers that aren't perfect, and so let's look at what happens with 18. So there's a lot of different ways that you can break down 18, and it won't matter in the end. I'm going to say that this is 3 and 6. 3 is a prime number, so I'm stopped there. But then I have 6, which is 2 and 3. So what I have is I have a 2, a 3, and a 3. That's essentially what the square root of 18 is. Well, what I need to do is I have to have groups of 2. And I have one group of 2 3's. So what that means is I can take 1 3 outside, because I can take one of them outside. Now, I don't have a partner with this 2, so it stays underneath. And so this is my answer. So this is 3 square root 2. All right, what I'd like you to do now is I would like you guys to try 4, 5, and 6 by just doing your factor trees. And then from there, see if you can find pairs. And then once you think you have it, you could press play. Okay, so 50 is 25 times 2, which is 5 times 5 times 2. Well, these partners are next to each other, so I'm just going to circle them. And so it's 5 square root 2. And again, there was nothing to go with the 2, so that's why it stays underneath. 27 is 9 times 3, which is 3 times 3. And again, in order to take them out, you have to have 2 of them. So I'm going to take out 1 3, and then this is left underneath. 72 is bigger, so let's see. We got 9 times 8. 3 times 3, which that tree's done. 2 times 4. 2's done. But then 4 is 2 times 2. So these are all the numbers I have. Let's see. I got a 3, 3, 3, 2, 2, and 2. So we need to figure out what can go together. And again, you have to have groups of 2 to go together. So I have one group of 2 3's and a group of 2's. And so I can take a 3 outside. I could take a 2 outside. But inside is what's left over that doesn't have a partner, and that's 2. Now, when you have this, you have to look and see what the product is on the outside. And 3 times 2 is 6. So the answer is 6 square root 2. Okay, I'm going to help you set up number 7, and then you guys are going to try 8 and 9 on your own. So we do the same idea. We kind of just ignore this 3 for now, and we'll come back and look at it. Right now, we're just going to break down 18. 18 is 9 and 2, which is 3 and 3. There's my pair of 3's. So I can take a 3 out, and this 2 is left over. But here's the thing you have to be careful of. This 3 was out front, so I have to put it out front again. So now I'm going to have another 3 out front. It doesn't become 33, it becomes 3 times 3. And 3 times 3 is 9, so the answer is 9 square root of 2. Okay, you guys go ahead and try 8 and 9, and when you think you have it, go ahead and press play. Okay, so 120, I would do 12 and 10. 6 and 2. 3 and 2. Okay, so that's all done. And then 2 and 5. So let's see, I have a pair of 2's right here. So I could put a 2 outside. I also have to put this negative 2 outside, so I'm going to bring that down. And then my square root, this one we've never had so many things left in, but this is what we have. We have a 3, a 2, and a 5. So 3, 2, 5. And now we do outside, outside, inside, inside. Negative 2 times 2 is negative 4. And on the inside, 3 times 2 is 6, times 5 is 30. So that's the answer. All right, let's look at 5 square root 75. 75 is 3 times 25, which is 5 times 5. And I have a pair there. So I'm going to take that one out and bring down the 3 inside. But then again, I got to bring out this other 5. And 5 times 5 is 25. So the answer is 25 square root of 3. And that's it. So factor trees are helpful. Sometimes they take up some space, but the more you do, the faster you get at them. And remember, in order to take a square root, you have to have a partner to take it out.